This is going to start session 2 of today's workshop on perspectives on traditional field geology and modern tools. Our first speaker is Dean Eppler, and he will be speaking on field geology in the Apollo era.
If we can go ahead to, there we go. I think we're in presentation mode and go to the second slide. The purpose of this presentation is to really try to explain to people how Apollo did field geology. I had developed somewhat of a reputation of an Apollo historian, and that's largely because most people don't really know what happened on Apollo. So there's a lot to be learned by going back and what they did and try to apply it to Artemis. So I want to talk about the history, document their practices, and consider the integration of new tools into the suite of hardware available for Artemis field ops. And this presentation is really designed to segue into Jack's specific talk about his experiences on the lunar surface. I want to make sure people understand that if your history of Apollo comes from the Discovery Channel, you probably don't know much about Apollo. So next slide. One key observation I want to hit right up front is the Apollo crews were extensively trained in the techniques of field geology, and they conducted detailed field geological investigations of each site, particularly the J missions, 15, 16, and 17. There are a lot of people out there that assume that the Apollo crew members simply went from spot to spot on the directions of the Capcom, picking whatever rocks seemed to be around without any plan. And in fact, they were carbon-based robots, and that was not what happened. We need to really look at how Apollo did stuff when we start really considering how we're going to do Artemis. So next slide. Everybody should know the basic statistics. We had 6 surface missions, 14 total EVAs, brought back 300 kilograms of samples, 11 geologic traverses, and deployed 6 geophysical/space physical monitoring stations. I think there's probably no argument that Apollo geologic activity, the results of that activity completely revolutionized how we see the history of the solar system, particularly the Earth-Moon system. And that understanding came from both the field observations and the return samples from the crew. Next slide. So field geology as it was done on Apollo was a little different from terrestrial field geology. And essentially what happened was that once the Apollo Site Selection Board, the ASSB, and it's the Group for Lunar Exploration Planning, which had a tremendous input into the process. Once they had settled on a site, then the USGS and NASA, particularly Johnson Space Center, took that site and started developing a detailed set of traverses and requirements for the operations of the crew. It's really important to recognize that every site was selected based on the knowledge picked up from the previous sites. So for instance, 16 was selected because they wanted highland samples well away from where Apollo 14 and Apollo 15 was, and well away from the Maria. Similarly, 17 objectives were to explore a complex geologic relationships that were be found in that intermontane valley as part of the Ceratonos Basin, and also to have a geologist as part of the surface crew. Next slide. The Apollo program, or the Apollo Field Ops program, was not a pure geologic mapping program, unlike what most of us do when we go to the field. It was a selected detailed sample selection based on the pre-mission photogeologic mapping done by the USGS and NASA. The idea was that you started out with a photogeologic map, you used that to generate traverses and sample points. The crew went and executed it, and then you took the sample results along with the geophysics and the documentation and worked it all back into effectively a geologic model of each site. A bunch of us listed there, specifically Jake, Cindy, John Gruner, Deborah Hurwitz, Jim Skinner, Peggy Whitson, and Wanda Feng, went out to the San Francisco volcanic field as part of MAMA 13 to test whether this was a good idea, whether it was a competent model. And I think we came up with the idea that it really was a good way of doing that first order geologic investigation. Next slide. So there was an evolution of complexity and duration from Apollo 11 to Apollo 17. The science objectives blossomed from Apollo 11, when really the science objective was grab something and bring it home, to the very detailed field studies done on Apollo 15, 16, and 17. The time on the surface increased from 2 hours on a single EVA on Apollo 11 to 3 7 to 8 hour EVAs each on 15, 16, and 17. A real critical part was that the program became more comfortable with landing in topographically challenging but geologically interesting areas. If you look at the criterion that were used to pick Apollo 11 and you apply those to Apollo 17, you find out that in fact, we would have never landed on Apollo 17 on the first mission because it simply failed the safety criteria. But by Apollo 17, we were comfortable with landing at that place. And the same goes for 15 and 16. The LRV opened up huge access to the surface. The Apollo 11 crew barely got 100 meters away. The 17 crew traveled almost 10 kilometers away from the limb, and they ascended up a number of approximately 20-degree slopes. This evolution was all made possible by a management decision by George Low early in the program to increase the performance of the limb to the Block 2 limb, which gave you the down mass to bring all that stuff down to the surface. So this was a conscious decision by Apollo management to improve what we could do. Next slide. So geologic simulation-based field training was the critical element to Apollo training for field geology. Starting with Apollo 13, there was some pack feed in Apollo 12, but it really came to its fore in Apollo 15, 16, and 17. Every one of the crews underwent extensive geologic training. When I tell, for instance, the mission ops guys who do training that the Apollo J mission crews spent 1 week in the field every month from the time they were selected as crew members until they flew, they roll their eyes and don't believe me until I show them the data. In all, the Apollo J mission crews had as much as 1,000 hours of science training by the time they flew. The training emphasized field observational skills and the sample documentation procedures so that the geologic context could be understood within the framework of the USGS and NASA pre-mission geologic mapping. Field training started in 1965, and they taught basic observational skills, doing things like going to the Grand Canyon. But by 13 through 17, it had evolved to full-up dress rehearsals for the missions, using the site observation, sample selection, documentation procedures developed by the USGS and NASA. Guys like Gene Shoemaker, Gordy Swan, Bill Mulberger, and a whole host of folks. And this was training that took place in the field, not in a rock yard. Next slide. So this is just an overview. I'll just leave it for everybody to look at if they download the slides, but this just gives you an idea of how much training the 15 and 16 and 17 crews had before they went to the moon. Next slide. If you want to know how many field trips they went on and who went on them, on the left axis are all the field trips with Apollo 15 in green, 16 in purple, and 17 in blue. On the top axis is all of the geologists that participated in the training, and X's in those columns are the trips they went on. So you look down, you can see that George Ulrich, for instance, went on 28 field trips in about 2.5 years. They did a lot of training. Next slide. So this is Jack and Gene at the Central Nevada Volcanic Field. They're wearing PLIS simulators. They have sunglasses on to simulate what the visors will show them of the colors in the rocks. And they have cameras mounted in the same geometry as they would have in the PLIS, so they can get good photographs. You may or may not have noticed that there was no viewfinder, so that they had to point their body to take the pictures, and that was a significant part of the training. Next slide. This is a back room. Bill Mulberger on the left, Tony England centered, Mike Dents on the right at Sudbury. Next slide. And it's important to point out that they limited the miserability of the training to things that only needed to have the pressure garments on. So things like deploying the LSEP and actually doing the documented sample procedures, which were critically involved with 2 crew members. So they practiced these on rock yards, but otherwise they did not use pressure garments in training. Next slide. So the EVAs were planned in detail and executed by the crew to maximize the use of the limited surface time and staying within ops and safety flight rules. The planning activities were not about constraining the crews, it was about keeping them safe. And the reality was the air-to-ground information stream was largely one way, moon to earth, not the other way around. The Capcoms only got involved when they were answering crew questions or to give them reminders of, the operations timeline. The ground teams, the MOCR and the SSR teams were there to watch, collect real-time observations based on the crew descriptions, to act as third pair of eyes for safety, and to integrate the crew context description in the pre-mission planning, not to interfere with or drive the astronauts around on the moon. Next slide. EVA time was precious. Even on J missions, we were limited to about 7 to 8 hour EVAs, 3 EVAs per mission. As Jim has often said, and I agree, the critical concept was the 3 trees: train them, trust them, turn them loose. Geologic field training was the key to how well we did. The crews were trained to, in particular, to do hand specimen description in the sea of minerals in the rocks, and they were trained in what they might see, but they were also trained to expect the unexpected, such as in Apollo 16, where they were expecting ash flow tufts and got breccias, or 17 when they found the iron soil. And they were trained to be able to take those changes in stride and execute the mission in spite of any misconceptions in pre-flight planning. Next slide. So real-time geologic descriptions on Apollo did not require any more detailed than hand specimen level descriptions and samples in mineralogy. For example, Dave Scott had the training to understand he was seeing twinning and plagioclase when he spotted 15415. He did not know it was AN98, and that was superfluous. The fact that they did not know it was AN98 did not affect their ability to collect and document this sample. Similarly, when Jack spotted the orange soil, he didn't know that it was glass beads full of titanium. That was immaterial to the fact that they were documenting field relationships. Next slide. So, as I said before, the SSRs operated in an observational mode, and if necessary, forward planning. They did not alter real-time EVAs. They did not change what was going on while an EVA was underway. There was some replanning that was done with respect to equipment failures. So, for instance, the SSR on Apollo 15 helped replan the 3rd EVA because of the problems with getting the core out, and they ended up skipping the Earth complex. Yep. Okay. And Apollo 17, they discussed whether to send the crew back to the Station 4 on the 3rd EVA, but decided not to, thank goodness. So, next slide. Some implications for Artemis. EVA time will always be precious. I don't care if it's the first mission or the 45th mission. Every time you get on a Plis, you're breathing down that Plis, and you don't have an infinite amount of time, and you don't have an infinite amount of endurance. EVA is hard physically, even with the quality of the suits and gloves we have, and I know that because I got 250 hours in the Mark III pressure garment. The tasks conducted on the EVAs have to make the most efficient use of that EVA time while getting the context data to enable us on the ground to understand what's going on. Anything that can be better done in a pressurized environment or in a lab on the ground should be done in those places. Next slide. The use of analytical hardware will never be a substitute for good training. And believe me, there are people out there smacking their lips out of saying, we'll give them tricorders and we don't have to train them. We need to disabuse the world of the notion that good field work is purely about detailed chemical analysis. We have to get the context so we understand what that analyses are. If the crew's not trained well, we cannot expect our science return to be equivalent or better than Apollo. Next slide. And I think I'm almost done here. Again, astronauts are not carbon-based robots. If we have to tell them what to do on the lunar surface, then we've either trained them poorly or picked the wrong astronauts. The independent decision-making of the Apollo crews made the difference on Apollo, starting with 11 and going all the way through 17. Next slide. Handheld instruments may be useful, but they've got to earn their place on the manifest by proving they can increase the science return and not drive the crew batty and make inefficient EVA time. That just has to be what we've got to think about. So, and I think that is my last slide.
Great. Thanks, Dean.
There are a bunch of detailed data on this stuff. If you would like to get a copy of these things, next slide. There, if you can't find them on the web, there's my email. Please feel free to get in contact with me because there's been a lot written about all about the Apollo training, and it's worth looking at. And I think that's my last slide.
Great. Thanks, Dean.